For problem 20, a graph is given to the right. Explain why the graph has at least one Euler circuit. Use trial and error or Fleury's algorithm to find one such circuit. So as I look at this graph to the right, vertex A, 1, 2, 3, 4, degree 4. C is 1, 2, 3, 4. E is 2. B is 4. D is 2. They're all even, so it has an Euler circuit. Choose the correct explanation. A says it has no odd vertices. If there's no odd, that means they're all even. That's the one. B, I'll read the others because you got to be careful here. B is it has no even vertices. Well, that's just simply not true. C is it has exactly 2 odd vertices. That's not true. D, all graphs have at least one Euler circuit. That's not true. Okay, go with the first one. Write an Euler circuit starting at A. Read the questions. I've had students in the previous semesters, they'll come in and we'll look at the test, and they've given an Euler circuit, but they didn't start at A. Like, oh, what do I do? You know, because you knew what to do, you just didn't start at the right place. If I start at A, I can go A, I think I'll go to, let's go to D. A to D. If I go there, after D, I have to go to B. Let's go to E. If I go to E, then I got to go to C. So I might want to draw this graph on my scratch paper. A to D, to B, to E, then to C. Trace through your drawing with a pencil or whatever you're writing with so you can keep track of what you've done. Here I'm going to go to B and then A. So after that C, B, A, then I'll go to C and then back to A. So right here, one of the edges that goes to C, the other one that goes back to A. There is more than one correct answer. Be careful when you type it in. If you type something like a period instead of a comma, the computer's not looking for that. It's going to mark it wrong. Number 21, explain why the graph shown has no Euler paths and no Euler circuits. Well, it is connected. Let's check out the degrees. A is 3, D is 3, E is 2, F is 3, G is 2, B is 3, 1, 2, C is 4. But once I got 3 odds, I'm done. That's why. By Euler's theorem, the graph has no Euler paths and no Euler circuits because it has all even vertices. Well, that's not true. Part B, by Euler's theorem, the graph has no Euler paths and no Euler circuits because it has an even number of odd vertices. That's a true statement, but that's not the reason why. I'll just put no. By Euler's theorem, the graph has no Euler paths and no Euler circuits because it has exactly 2 odd vertices. That's not true. If it had exactly 2, it would have an Euler path. Must be the last one. By Euler's theorem, the graph has no Euler paths and no Euler circuits because it has more than 2 odd vertices. Yes.